friends, and welcome to our new series of lessons on the industrial communication and protocol. So we will discuss about the OPC, OPC UI, Modbus, Profibus, the MP3, and we begin with the OPC. First we will study the theory, what the OPC is, why it is used, and how it enables communication between the SCADA system, PLC, DCS, and our industrial and other industrial devices. After that we will move on the practical example and configure the communication step by step, and during the courses we will also cover the most widely used industrial protocols and communication technologies. So my friends, before the OPC, every SCADA system had to communicate with each device using its own dedicated driver. Let's look at this picture, at this diagram, and on the left side we have a SCADA system, this one, and on the right side we have different industrial devices, PLC, PLC1, EID1, and so on. Before the OPC, as I said before, the SCADA software need a separate communication driver for every devices. For example, PLC1 might use the Siemens protocol, so SCADA needs a Siemens driver. PLC2 might be Bradley, so SCADA needs a different driver, and ED1 must use another manufacturer protocol requirement, another driver. And as you can see, every device requires its own driver, and my friends, the simple analogy is, imagine you speak only English, but your friends speak German, French, Spanish, and Japanese. Without the interpreter, you will need to learn every language. So nowadays the English language is used like the OPC. We can say that. This is exactly how the SCADA worked before OPC. Every time a new device was added, the SCADA vendor had to develop or install another communication driver. And my friends, as the number of manufacturers is increased, the number of drivers also increase, making the system more complex, harder to maintain, and more expensive. And my friends, so what changed after OPC was introduced? Instead of SCADA system having to communicate with every device directly, a new layer was introduced, and this layer was the OPC server and client. Now the SCADA system no longer needs to know how to communicate with each PLC or EAD or another devices. Instead, the SCADA system acts as the OPC client. So you can see it here, and the OPC client communicates with the OPC server, and the OPC server communicates with the field devices. So the communication path becomes SCADA, OPC client, OPC server, and then the industrial devices on the plants. So my friends, the OPC server is that the interpreter. The SCADA system only needs to know how to communicate with OPC server, and OPC server takes care of communication with the Siemens PLC, Allen Bradley, Schneider, and another devices. And my friends, let's talk about this picture. On this side we have three main components: the PLC, this one at the bottom, and the OPC server in the middle, and our OPC client, which could be an HMI or SCADA system or another software application. So my friends, in this example, the Siemens S7200, which use the PPY protocol or another Siemens protocol dependent on the model. The important point is that not speaking OPC. The OPC server understands the Siemens protocol, and it's read the data from PLC. OPC server read the data from PLC and convert it to OPC standard and makes it available to any OPC client. So the OPC client does not need to know anything about the Siemens protocol. It simply requests data from OPC server, this one, and show the data on the screen. So my friend, the communication flow is the PLC and PLC Siemens, and Siemens use the native protocols. Then we have the OPC server, and OPC send data to OPC client, which run on the HMI or the not HMI, my friends, maybe on SCADA. But if you use the HMI belong to Siemens, you don't need the OPC, and if you use another SCADA system, you must install the OPC server. So my friends, if the conclusion is, if you use the same device from the Siemens and Siemens software, Siemens valves, Siemens transmitters, and another devices, you don't need the OPC. You use the OPC when you use the different system. So my friend, and at this picture we have another interesting things. The SCADA system acting as a boss and OPC client and OPC server now, and how it's possible. First, the SCADA works as the OPC client. It's received the live data from APC server which connected to PLC. Then the SCADA publisher this data again as an OPC server. And why would it do that, my friends? Because another application want to use the same information. For example, you in the future, when we talked about SCADA deeply, you will learn that SCADA has a different purpose. And for example, the first purpose here is the historical data. Instead of connected directly to PLC, the historian simply connect to SCADA application and get data from them. And my friends, before we finish this lesson, let's answer an important question. What does OPC actually stand for? Let me open my notepad. And OPC is stand for the OLE. It means the object, linking, and embedding for process control. So for process control. So my friends, the object linking and embedding, it's a Microsoft technology that allowed Windows application to exchange data, and process control refers to industrial automation and process control system. Today, however, most people simply use the name OPC because modern versions like the OPC UI are no longer based on the object linking and embedding. And my friends, the last thing I want to explain you, maybe you know about it, but it's question about how the OPC server actually get the data. It's very common misunderstanding. Many beginners think that the POC somehow speak with OPC, and it doesn't. The POC continues to communicate using its own native industrial protocol. For example, Siemens used S7 protocol suite, and Alan Bradley used Ethernet IP or SIP, and Modbus device used the Modbus RTU or Modbus TCP, and Yokogawa used the FCS protocols. So my friends, the OPC server contains the driver for that protocols. So internally the OPC server is doing exactly what the SCADA driver used to do. And my friends, let's see the process step by step. Firstly, the OPC server send a request for PLC, and here my friends, you can use the tag, or you can for example, you can use the address, and for example, if you have some data in the DB1 and DBW10, so OPC server sent a request for PLC, give me the tag or give me the value from this address, and PLC replies using its own native protocol. So PLC reply to OPC server using its own protocol. Then OPC server received the raw data. OPC received raw data from PLC. Then my friends, the OPC convert raw data to its own OPC format. And finally my friends, OPC client can read it. So my friends, that's all for today. I wish you we will start our practice, our 5 or 6 lessons, and I wish you good health and good life. Subscribe to our channel and hit the like button if you enjoy the video. See you in the next lesson.